Welcome to the LOYTEC Support Tech Talk. My name is Kevin Koll and we will be looking at historic data. First, we will look at different methods to record historic data as well as their differences. Following that, I present details and examples for trends and historic filters. There are two ways to record historic data. On the one hand, there are trends. These capture the value of a data point over a defined period of time and map the historical change in value over time. On the other hand, there are historical filters, which are state snapshots of historical points in time mapped onto data points that can also show mathematical correlations. This means that if you want to record a value progression, then the trend is the right tool. However, if you want to record a value at a certain point in time, for example, an electricity meter reading at the beginning of the month, then historical filters are suitable. In addition, it is also possible to combine the two together. Let us first look at the trends in detail. All data points can be trended regardless of which technology they belong to. Trend objects can be created as BACnet, LON, or as a generic trend. The difference here is essentially that the trend data can be called up upon on the respective technologies. When creating a trend object, the name and description for the trend can be entered. However, our main interest is the trend mode, as this determines how the data is recorded. There are the following choices. In the interval trend, the data point is recorded over a definable interval. The log size and the defined interval are used to calculate and display the recording length. If the recording length is adjusted, the configurator automatically calculates how many more or fewer log entries the trend needs to display the desired recording length. Optionally, the interval recording time can be aligned with the start of the hour and be shifted in time from the start of an hour. A trend based on change of value, or COV, only logs when the value of the recorded data point changes. In contrast to an interval trend, only the log size can be defined here. That is how many value changes are to be recorded. The actual duration of the trend depends on how often the recorded data point changes in value. The more often it changes, the more often the log entries are created. Depending on the application, it may be advisable to select a sensible COV delta to prevent recording data unnecessarily often. Lastly, there is also the trigger option. Using this option, a data point is only recorded once a freely definable trigger triggers. To trigger the recording, a Boolean expression is used in form of a Boolean data point. This allows recording of a data point only when the expression is met. There are various situations where one might want to do this, for example on an active alarm or when a device turns offline. To better illustrate the trend modes, I have already created an example configuration here. I have configured several trends with the different trend modes that record an energy meter. For example, there are also two COV trends here, one with and one without COV delta. A trend can be viewed at any time via the web UI of the device. Via the menu item, data, and then trend, all the items on the device can be viewed here. Let's take a look at the interval trend first. This has been given an interval of 5 minutes. That is, a log item is created every 5 minutes. The trending values and times can be viewed by using the time slider. We can see here the recorded value as well as the recorded timestamp. In comparison to that, we can view the COV trend without the COV delta. One can see that a lot more values are recorded here. We can see also again here the COV trend with COV delta. It is very noticeable that here are less items recorded, and the COV delta is 10. We can see this in the gap here. And lastly, there is the trigger trend. This only recorded values when a trigger has been met. This could be in a real application also triggered by schedulers and other such things. Let us look into the storage modes of a trend. There are two storage modes for trends, ring buffer and linear buffer. The storage modes essentially determine how the set log size is maintained, as well as which order the log items are stored if the set log size is exceeded. In the ring buffer mode, old entries are overwritten when the capacity of the log is reached. In the linear buffer mode, older entries are expired so that new entries can be added. Finally, there is an option called Save Trend Data Externally. If this option is selected, a backup of the trend is stored on an external storage medium, for example, an USB stick. The fill level notification level determines at which percentage a backup is made. To enable this feature on a device, the USB stick must be integrated through the web UI and the trend backup option must be enabled. In order to process these trends in other applications, there are various possibilities to read out or send trend data from the device. To name a few, trends can be downloaded specifically from the web UI in a CSV file, or all the trends can be collectively downloaded in a zip archive. In the configuration of the device, you can also set up so-called email templates, which can be used to send trend data by email in a CSV format. Via SFTP or SCP, you can directly access the file system of the device and download the trend data as shown in the console here. Let us now turn to the configuration options of historical filters. Since historical filters, in contrast to trends, are snapshot captures, the configuration is representing capture times. When this capture should happen, can be set using the drop-down menus in the columns type, day, and time. The values in the samples ago column indicate how many recordings in the past the value is snapshotted from. As an example, if we want to set a filter so that a value is captured every X minutes aligned to the full hour and select 1 minute in the time column, a value will be captured every minute. If we enter a 1 in the samples ago column, then the capture is not the value from 1 minute ago, but rather represents the capture that was made a minute ago. One can also think of it as shifting the capture in time 1 minute backwards. However, this is not the same as when a capture was made 2 minutes ago, as this would only capture values every 2 minutes. Should you want to automatically calculate a value difference to a current value, for example, every 2 minutes, you could capture the value 2 minutes ago and subtract it from the current value using the subtract from column. This functionality can be used to automatically calculate energy consumption over a specified period, in this example 2 minutes, but could be extended over days, weeks, and so forth. To illustrate this, I have made a trend capture of those filter entries to give a visual representation. I already opened the web UI to show this trend. In blue, we can see the recorded values of our baseline data point. And in green, we can see the capture that was made every 2 minutes ago. Notice how it captures the values for 2 minutes respectively. In pink, we can see the difference to the capture that was made 2 minutes ago and the current data point value. This is why it represents a sawtooth signal, as the signal shows the error between the blue and green signal respectively. In other words, this represents the change of value between the capture and the current value, and thus is useful for tracking consumptions of energy meters. Of course, in a more realistic scenario, one may want to extend this 2-minute capture frame to a much longer time frame. One can select in the type column all kinds of capture methods, such as every day, at a given time, weekdays, months, and years. Noteworthy is that if one has an energy consumption meter, then one can think of several scenarios when the energy counter could reset or change. For example, when replacing the energy meter with a new one. To accommodate such a scenario, the type offset correction allows entering the old meter's counter in order to provide a continuous capture, as this would offset new filter values of the current meter count so that there are no unexpected gaps or jumps of filter values. To show a more realistic example, I have integrated an Embus energy meter into this configuration, which provides us with energy meter readings. I also already created an example for a historic filter, which captures the meter count every full hour, as well as calculating the difference between the set capture and the current reading of the energy count meter. This would show us the energy consumption in a given hour. As I already did previously, I made again trends on this historic filter data points to further illustrate this behavior. I already have this trend open in the web UI, and we can see exactly this hourly energy consumption. Again, of course, this can be set to a much longer period as well. And exactly this behavior can also be observed in the CSV file that can be downloaded through the web UI or other previously mentioned methods. For example, as we can see here, the start of the capture time as well as the start of the consumption reading. And this file could be further evaluated by third-party processes. And with that, I conclude this Tech Talk, and I would like to thank you for your attention. I would also like to invite those of you that have any questions regarding historic filters and trends to stick around, and I will be happy to oblige to answer them.
Yeah, I mean, actually, maybe two comments that were not in this presentation. One thing is that what we had this subtract from, or let's say in a different way. Typically, you use historic filters when you have a counter. You have an energy counter that is just continuously counting up, and somewhere you want to display the power consumption over the last 15 minutes, the last day, the last week, the last month, whatever. What you can do is, here in this presentation, we showed how you can calculate the difference. So basically, you say I have my recorded value at the beginning of the day, and I'm taking the current value, and I'm subtracting the value from the beginning of the day from my current value. And in that case, I would have the consumption that I had since midnight. But of course, you cannot only subtract from the current value, but you can also subtract from another value more samples before. So basically, you can say, I want to subtract the value from today or from yesterday midnight from the value today midnight. So then I get the consumption of the energy from yesterday. And that way, basically, you really not only get a continuously usage, where we have this sawtooth thing, but you really have the values. And this is something you can also trend and which can be used. And the nice thing is that you can set up such a list of historic filters, like I calculate the value for the last hour, for the last day, for the last month, for the last year, whatever. And then you can save all this information into a file, and then you can import it in a different project, and you can apply it to all these trend logs. So you do not need to recreate it for every trend log, but you just do this once like you want to have it, and then you apply it to all trend logs in all your projects that you want to have. And that's actually quite a nice feature that works pretty well, I think. What we added, I don't have an example here, but what we added in one of the last firmware versions was that you can also manually enter values for historic filters. Because in the past, the problem was that, or in the past, a frequent problem is that you want to, you create a new log file, and you want to display the power usage from the beginning of the year or beginning of the month or whatever. But in order to do so, you need to wait until the next January 1st so that you can record this sample, and then from that you can use this feature. Or maybe for some reason you have to, I don't know, exchange the device, or you start a new project or whatever, something happens and you lose your old trend data, then you need to start right from the beginning. But in the new firmware version, I think we put it in 7.6 Links firmware, you now can enter manually these values so that you can initialize the values on the web interface, and these values are then used to calculate all these recordings and data. That's quite a new feature, actually.
Maybe to pick up on the samples ago column, where you can pick up the date from yesterday and or maybe the hourly consumption from 1 hour ago. You can also use them to draw comparisons, as Norbert said. So you can have like a immediate comparison of, oh, I used so and so many watt hours more or less in comparison to the last item. That's also something you can set up if that's something that is of interest. Maybe with days or something, you can use it to directly do these calculations, which you would otherwise do in a math adapter.
Yes, well, because in the visualization, actually, what you can when you have a trend, then you can only display trend data, basically. I mean, you have a trend log and you can display the trend data inside of a trend log. But what you cannot do is you cannot read out the data, the trend data from a specific date or time and display this value in LWeb or LWIS. That's something where you cannot access it. The only way you can use the trend is put it in a trend log, or you can use the trend log, put it in a trend chart. But with historic filters, you, for instance, can say, okay, I'm recording the energy consumption from today, yesterday, 2 days ago, and so on. And then you might have maybe 6 or 7 samples, and then you use these and put it maybe in bar graphs and show these values and compare them. So that's a good way to show data in some kind of dashboard style. That's what we do quite often, actually.